When you're programming industrial machinery, one single wrong line of code, well, it can have some pretty big real-world consequences. So how do you safely test something or disable a piece of logic without just deleting it? Today, we're going to pull back the curtain on a programmer's secret weapon for doing just that. It's kind of like a hidden off switch, known as the always false instruction.
I mean, we've all been there, right? You're troubleshooting, you're hunting down a problem, and you've got a feeling that one specific line of logic, one rung, is the culprit. You need to take it out of the equation for a minute, but you definitely don't want to delete it because you're going to need it later. So, what do you do? Well, to solve this exact problem, Rockwell Automation built this beautifully simple solution right into a lot of its platforms. It's called the AFI, which stands for Always False Instruction. And honestly, it's designed to be the perfect, temporary, non-destructive off switch for any line of code you've got. Okay, the absolute best way to picture the AFI is to think of it like a permanently open switch in an electrical circuit. It doesn't matter what else is going on in that circuit, electricity just can't flow through that one open point. The AFI does the exact same thing for your code. It creates a hard stop, basically telling the processor, hey, the condition on this line is false, period, end of story. So how does this actually work during a PLC scan? You know that lightning-fast cycle where the controller reads and executes your code? This is a really crucial point. The AFI doesn't make the processor skip the line of logic. Nope, the processor still reads it, but as soon as it hits that AFI, it evaluates it as false. This immediately forces the entire rest of the line to also be false, which then de-energizes the output. It's not ignoring the code, it's actively neutralizing it for that cycle.
But this simple instruction is way more than just a one-trick pony. It's a super versatile multi-tool that programmers rely on all the time for debugging, for developing new logic, and most importantly, for making sure things are safe out on the plant floor.
Its uses really fall into a few key categories. The most common one is definitely troubleshooting. Think of it like your magnifying glass, where you disable a line of code to see if a problem goes away. It also works as a great placeholder, kind of like a blueprint. This lets you map out a program's structure with AFI lines and then fill in the actual logic later. And critically, for safety, programmers will often add AFIs to all the outputs before a first download to a new machine. It's a simple way to prevent anything from firing up unexpectedly.
So the AFI sounds pretty useful, right? I mean, it's awesome. Well, here's the catch. This handy little tool, it isn't available in every single programming environment. And this creates a classic scenario for programmers. What in the world do you do when your favorite tool is missing from the toolbox?
And this is where it gets a little tricky. If you're on a modern platform like RSLogix and you're using Studio 5000, hey, the AFI is right there for you. But if you're working on the incredibly common SLC 500 or MicroLogix controllers with RSLogix 500, it's just not there. It's missing. So what's a programmer supposed to do?
This is where the real ingenuity of programming comes into play. Over the years, programmers have developed several pretty clever workarounds to simulate the AFA's function when the instruction itself just isn't available. They've essentially built their own always false conditions right from scratch.
So these are the main methods people use. The safest, by far, is using what's called a never true internal bit. But I want you to look at that second option, using an address that's tied to an unwired physical input. The source material is very clear that this is high risk. And why? Well, just think about it. What happens if maintenance comes along and wires something to that unused terminal? All of a sudden, your disabled code could come roaring to life when you least expect it. That is a risk you just cannot take.
So yeah, that brings us to the bottom line. While there are a few clever hacks out there, only one method really stands out as the clear winner. It's recognized as the industry standard because it gives you the safety and the clarity that you need for professional, maintainable code.
So what is the right way to do it? It's actually a pretty simple process. First, you find an internal binary bit. That's just a simple on-off switch in the PLC's memory that isn't being used anywhere else in the whole program. You give it a really clear name, something like system_false, so it's super obvious what it's for. Then you place a normally open contact, an XIC instruction that just checks if a bit is on, right at the start of the line you want to disable, and you point it to your system_false bit. Since nothing in your code ever turns that bit on, the contact will always be open and that line of code will always be false. It's simple, it's safe, and it's incredibly effective.
At the end of the day, this isn't just about some clever trick. It's about writing code that is robust, that is safe, and that's easy for the next person who comes along to understand. Choosing the right method to disable code is really a hallmark of a professional programmer who thinks not just about making it work right now, but about making it safe for the long haul.
And hey, if there's any doubt, this quote from the source material just makes it crystal clear. Using a dedicated, globally unused internal bit, it isn't just one option, it is the standard and safest practice. That right there is the key takeaway for anyone working in that RSLogix 500 environment.
So, the always false instruction, or its simulation, is a really powerful tool for safe testing, which kind of gets me wondering, what other techniques do you rely on? What's your go-to trick for testing code safely and effectively when you're working on live systems? It's such a critical skill in this field, and, there's always more to learn.